Hello everyone. Today we're looking at another Leetcode problem. This is 2200. Find all k distant indices in an array. This is an easy problem, but an interesting one. So we have been given a zero-indexed array called nums, an integer value key, and integer value k. A k distant index, is an index I of nums array for which there exists at least one index j such that the absolute difference between these two indices is less than or equal to k and nums of j is equal to k. We have to return the list of all k distant indices in a sorted order. Let us understand what this means. So let's say if this is my index j and nums of j happens to be key, then what we are saying is that there are few indices such that j minus k and j plus k is a range, and all of these values which will be an index I is a k distant index because they satisfy the condition. So think of this j minus j, or let's take the absolute difference, right? So j minus j is equal to minus k, and the difference is absolute difference is k. Same way, j plus k minus j gives me k, which is an absolute distance of k, and j minus j, which is equal to 0. So these all values satisfy the condition lesser than or equal to k. Now what we need to do is we need to identify these indices and finally return these that were discovered from this particular key, and maybe few other indices which had the value key, and we need to have them stored somewhere and return in the sorted order. Okay, so one of the important thing for us to think about here is the worst case complexity, right? So if my first element happened to be key and my second element happened to be key, and let's say all of them happen to be key, and let's say my k is equal to n, then what we're saying is that for this particular key I can look forward n items and backward 0 because this is the 0th index. But when I come to the first index, I can look forward n minus 1 and I can look backwards 1. And I do this again and again because all of the values are key. So what I'm ending up with is time complexity of n squared because that many operations I'm doing. Now, this is clearly, this is okay because the constraint, if you look at the constraint of the problem, it says that the size of the nums will be maximum 1000, which means even if you do n square operation on it, you get to 10 power 6, which is well within the 10 power 8 TLE range. So this is okay, but there is a lot of repeated work, right? Like for example, key 1 is looking at all of these values, has taken up all of these values already and said that these are the k distant indexes. Okay, and apart from that it also did this, but this is a overlapping common k indices between key at 1 and key at 0. Okay, and so this was the only additional thing that both these keys have identified, like this key has identified this in the backward fashion, and for this key it was already part of the forward lookup. So there is very clearly a lot of repeat work which we can optimize. Another thing to note here is as we store all of these values, if we just do this, if you're looking at n squared times, and that means we're also storing n squared times. If you're just blindly taking the values and saying, okay, this is also k distant index, this is also k distant index, this is also k distant index, then the space is also like n squared. But then you can optimize the space at least by using a set operation, which will only take the unique, so it will give you order of n. But the problem with using something like a set is that this one in Python is unordered, which means because set only takes the hashes of those values, it doesn't maintain the order, which means you will have to sort it before you return it. So you end up using n log n time complexity here. So can we do better given these issues that we're looking at? And the answer to that is yes. So instead of using list or a set, which is just like a blind data structure and it's just storing whatever it's getting, what if I use a flag array, okay, or a list, which is of the same size as nums? And what this means is I have access to all of these indices same as nums, and I can just initialize this with default of 0, and whenever an index becomes k distant index, I can flag it as 1. Okay, so that I don't need to, and when I read this, right, for returning the result, I just need to read this left to right and just return the response in order of n. I don't need to do additional operation to sort in all of those stuff here. Okay, so that helps me on the space side of things. Let's think about what happens when we come to the execution complexity. So for the execution complexity, we will look at two cases and understand this. So let's say this index j happens to be a key. And let's assume dot 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 is starting from some point. Let's say these indices also happen to be k distant indices. Okay. Now, depending upon my k, my k distant indexes can overlap with this, which means this is a repeat work of looking at these elements, which we can avoid because we know we have already seen something till here. So something as simple as last flag, which will hold the index of the last value, which was a last distant k distant index, will tell me that I should not go beyond this. So if I have to start setting k distant index, I can create, if this was my start of the range, I will use this as the start of my range. Okay, and these are the core ideas of the problem. Now let's look at the pseudocode, and the pseudocode will put all of these concepts together. Okay, so let's say def find k distant indices, and the input is, I'm not writing self because this is a pseudocode code. So let's say nums is a list of integer. Okay, k is an integer value, key is an integer value, and what we need to return is list of integer, which is basically the sorted list of k distant indices that we need to return. So let's see how we're going to do that. So first of all, let's create a flags list, which is by default initialized to 0. So we say for an empty variable in range len of nums. Okay, and then we say last flag is equal to -1 for index in range of nums. Now let's take a pause here and think about what is going to happen. So we're going to execute whatever we are looking at here only when we encounter a key. If you don't encounter a key, we don't need to do anything. So let's write that condition first. If nums of index is not equal to key, let's just proceed. Okay, but now let's think about what happens if you encounter a key. Okay, so when we encounter a key, what I need to do is first define this range so that I can collect this k distant indices, mark it in the flag array so that I can read it at once and return it at the end. So let's do that part now. So start is equal to max of last flag plus 1. Last flag plus 1 because last flag was already a k distant index, so we skip that. We do plus 1 comma index minus k. So let's recap this point, right? So there are two things that can happen. One is my last flag was here, and another one is that my index minus k is here. So if this happens, we want to take a max, which is this one here. And in another case where there is an overlap, let's say my last flag is here and index minus k is here, then we want to take last flag plus 1. Okay, whichever is greater. If this is greater, we take this. If this is greater, we take that. Okay, so that's my start. And end, we're going to take min of is it the end of the list, or we're going to say index plus k, whichever is the least possible. So for I in range of start to end plus 1, what we say is that flag of I is equal to 1. And then after all of this updation is over, I'll say my last flag got updated to end. That's about it for the code. And now once this for loop is over, I can safely return the indices. So I'll return I for I comma v in enumerate of flags if v is equal to 1. Okay, so this is the solution. Now let's also look at the time complexity improvement from the last time we discussed. Okay, so we spoke about the worst case complexity where every other element was a key and k was equal to n, which means for every key I was looking at n elements. Okay, so this is what was happening, right? So this is looking backward 0. This is what was happening. But now what is happening? Now what is happening is if this is marked, then I have already traversed these many things, and let's say this is the end. Okay, so my last flag has already become equal to len of nums minus 1. So when I take the start of it, the start, which is going to be the maximum of len of nums minus 1 plus 1, because I always added plus 1 to my last flag because last flag is already a k distant element. Now we want to start a new window from the next element. So now this is already out of bound. So the inner loop is not going to execute. So I'm just going to keep looking at all of the indices and not process anything inside it. So the time complexity of this reduces to log n from what we earlier had, which was n squared. That is it for this problem. Hope this was helpful. I'll see you guys again with another problem. Thank you. Bye bye.